Right now, while you are watching this, a machine the size of a grand piano is falling through the dark at the edge of the solar system. It is not orbiting anything. It is not heading home. It is traveling at 31,000 miles per hour, more than 4.5 billion miles from where you are sitting, in a region where the sun is just another bright star and the temperature hovers near minus 390 degrees Fahrenheit. And at this exact moment, that machine is still transmitting. It is sending back data from a world that humanity visited exactly once, for exactly 6 hours, on a single summer day in 2015. There is a body of discoveries from that day, confirmed by NASA and published in the highest ranked journals, that almost nobody on Earth has fully absorbed. And it directly affects the most important assumption we have ever made about our own solar system, that the outer edge is dead. Stay with me, because by the time this is over, you will understand that we found something alive at the edge of the dark, and then we turned away. I am Name, and this is Channel. Subscribe now, hit the notification bell, and do not look away. The machine is called New Horizons, and its appointment with Pluto began on January 19th, 2006. At 2:00 in the afternoon, Eastern Time, an Atlas V rocket lifted off from Cape Canaveral, carrying a payload that weighed just over 1,000 pounds. The expected lifespan of the primary mission was 9 years, maybe 10. The goal was almost modest: reach Pluto, take pictures, characterize the atmosphere if there was one, and continue into the Kuiper belt if fuel remained. It was not supposed to rewrite planetary science. It was not supposed to find active geology on a world smaller than our moon. It was supposed to be a reconnaissance flyby, a brief handshake with the last of the classical planets before it was reclassified and forgotten. That was the expectation. That was the contract. What actually happened is one of the most extraordinary single days in the history of exploration. Not because the spacecraft was more advanced than advertised, though it was, but because the world it revealed was warmer, wetter, and more chemically complex than any serious, peer-reviewed, rigorously tested model had predicted. New Horizons was built when Pluto was still considered a cold, dead, cratered relic. It was built when most researchers believed that nothing beyond Neptune could be geologically alive. The spacecraft was designed to confirm that assumption. What it did was destroy it. For decades, the models told the same story. Pluto was a fossil, a ball of rock and ice frozen solid for 4 billion years, preserved in the deep freeze of the outer solar system like a specimen in a jar. Serious, peer-reviewed, rigorously tested models. Planetary scientists built careers on the assumption that small bodies cool quickly and die young. It should be cratered from edge to edge, the model said. It should have no atmosphere, or at best a thin, escaping wisp frozen to the surface every winter. It should be geologically silent, chemically inert, and biologically irrelevant. The outer solar system was drawn as a morgue, a storage facility for leftover material from the formation of the planets. Step beyond Neptune and you left the realm of process. You entered the realm of history. That was the framework. That was the science. That was what every major institution, from NASA to the International Astronomical Union, presented to the public as the boundary of the living solar system. And within that framework, New Horizons was supposed to be a confirmation engine, a machine that would tell us, with better precision, exactly how dead the outer edge actually was. That is not what New Horizons found. On July 14th, 2015, at 7:49 in the morning Eastern Time, the spacecraft made its closest approach to Pluto at a distance of 7,800 miles above the surface. To put that in perspective, the distance from New York to Tokyo is 6,700 miles. New Horizons passed closer to Pluto than you could drive across the continental United States, and what it saw, when the images began to resolve, was not a cratered tomb. It was not a frozen wasteland. It was a world with a beating heart. A vast, bright plain of nitrogen ice, later named Sputnik planitia, stretching more than 600 miles across. Not a static glacier, not a dead sheet. A geologically active basin, churning with convection cells, resurfacing itself within the last 10 million years, which is yesterday in planetary time. Now, stop and sit with that for a second. Think about what that continuity of surface actually represents. A body smaller than our moon, 40 times farther from the sun than Earth, receiving less than 1,000th of the solar energy that warms our oceans. And yet its surface is being actively repaved. There is no impact crater record on that plane. None. Which means something is erasing them. But here's where the story gets genuinely important. Pluto is not just geologically alive, it is chemically alive. The spacecraft detected a blue haze extending more than 1,000 miles above the surface, layered with hydrocarbons called tholins. Not simple methane frost, not inert chemistry. Complex organic molecules, built in the upper atmosphere by ultraviolet radiation, falling back to the surface like snow, painting the landscape in shades of red and brown. To put that in perspective, the same class of molecules that may have seeded the early chemistry of Earth is forming right now in the atmosphere of a world we assumed was sterile, and then the data revealed something else. Right Mons, a mountain. 90 miles wide and 2.5 miles high with a depression at its summit, not an impact crater, not a tectonic ridge. A caldera, the signature of cryovolcanism, ice volcanoes erupting not with molten rock, but with water, ammonia, and organic slurry from a warm interior. If that interpretation holds and the peer review continues to tighten around it, then we are not looking at a dead world. We are looking at a world with a subsurface ocean, a liquid water reservoir kept warm by radioactive decay and tidal stress, venting organic chemistry onto the surface. Not a one-time anomaly, not an imaging artifact. A continuous process, operating for millions of years in the darkest, coldest corner of the solar system. But on July 4th, 2015, 10 days before the flyby, New Horizons nearly died. It did not happen in the engine. It did not happen in the power core. It happened in the software. A timing error in the command sequence caused the main computer to overload and drop into safe mode. The spacecraft stopped collecting science data. It stopped communicating normally, and for 1 hour and 21 minutes, the mission team at Johns Hopkins Applied Physics Laboratory in Maryland lost contact entirely. The component was 2.9 billion miles away. To put that in perspective, the distance from Earth to the Sun is 93 million miles. The spacecraft was 31 times farther. You send a command, you wait 4.5 hours for it to arrive. You wait for the spacecraft to process. You wait another 4.5 hours for the response. If wrong, you wait 9 hours more. A single wrong instruction, a single command that locked the system deeper into safe mode, could have permanently ended the primary mission. The pressure was absolute. The flyby was 10 days away, and the spacecraft was deaf. The engineering tension loop. You diagnose the error from 2.9 billion miles away using only telemetry. You craft a fix. You uplink it. You wait 9 hours for confirmation. You discover a secondary issue with the autopilot. You craft another fix. You wait again. Every hour of delay cost science observations that could never be repeated because New Horizons was traveling at 31,000 miles per hour, and Pluto's gravity was not strong enough to slow it down. There would be no second pass, no orbiting, no do-overs, one shot, one day. And the machine was silent. The engineers succeeded. They treated the spacecraft like a patient undergoing brain surgery without anesthesia, without a scalpel, and without being able to see the patient. They rewrote the command sequence. They restored the autopilot. They verified the memory state, byte by byte, across a 5.8 billion mile round trip. And in the early hours of July 7th, 2015, New Horizons came back online. Not weakened, not compromised, fully operational with all 7 of its scientific instruments ready. The relief was not just professional, it was existential, because the spacecraft did not just come back. It came back with more things to tell us. In the final 48 hours before closest approach, it captured the images that would reveal sputnik planitia, the blue haze, the mountain ranges of water ice floating in a sea of frozen nitrogen. The recovery did not save a mission. It saved a revelation. But the story is not over. It is entering its final chapter. Right now, in the summer of 2026, New Horizons is running down a clock that cannot be reset. Earlier this year, mission controllers at NASA completed a detailed power audit of the spacecraft's single radioisotope thermoelectric generator. The plutonium-238 core that has kept the machine alive for 2 decades is decaying on a fixed nuclear schedule. It does not care about discoveries. It does not care about Pluto. It converts heat into electricity less efficiently every year, and there is no refueling mission that can reach it. The generator produced roughly 245 watts at launch. By the time it reached Pluto in 2015, that had fallen to approximately 200 watts. Right now, in July of 2026, the output is hovering near 175 watts. To put that in perspective, the small light inside your refrigerator uses more power than the entire spacecraft currently has available to operate its instruments, heaters, and transmitter. In the spring of this year, the mission team began a procedure they call load shedding. Instruments are being powered down one by one, not because they failed, but because there is no longer enough electricity to run them all. The ultraviolet spectrometer, the plasma detector, eventually the imager. Each shutdown is permanent. Each one takes a piece of the mission into silence. On December 31st, 2026, New Horizons will pass 60 astronomical units from the Sun. By then, the round-trip light time will exceed 16 hours. And here is the part almost nobody outside the mission team is talking about. NASA has no plans to go back, no orbiter, no lander, no second flyby. The most extraordinary world at the edge of our solar system, a world with an ocean, an atmosphere, and organic chemistry, has been visited once, for 6 hours, by a machine now dying in the dark. And we are letting it go. Here's what I want you to take away from all of this. This is not a footnote. This is not a minor correction to an old textbook. If New Horizons discoveries hold, and the peer review continues to confirm what the images and spectra have shown, then the outer solar system is not a morgue. It is not a storage facility. It is a laboratory. The nitrogen atmosphere is not just a weather pattern. It is a shield. It is a filter. It is the condition that allows complex organic chemistry to accumulate on a surface without being destroyed by solar radiation. And if Pluto, a body smaller than our moon, at 40 times Earth's distance from the sun, can harbor a subsurface ocean and active cryovolcanism, then the number of potentially alive worlds in our own solar system does not stop at Europa or Enceladus. It extends to the Kuiper belt. It extends to hundreds of dwarf planets we have never visited, never imaged, never even named. Think about what that means. If the chemistry of life can persist at the frozen edge of the solar system, then the habitable zone is not a thin ring around a warm star. It is a broad, forgiving, chemically active territory that includes the darkness itself. And here is the unanswerable question that the dying instrument, with its decaying power core and its one-shot trajectory, is leaving behind. If Pluto has an ocean, and organics, and energy, and we left after 6 hours, how many other worlds are we ignoring? How many other oceans are we assuming are dead, simply because we have never pointed a camera at them? The solar system's edge is not a boundary, it is a shoreline, and we turned the boat around before we reached the water. New Horizons carries no golden record, but it carries something smaller and stranger. A capsule of ashes from Clyde Tombaugh, the man who discovered Pluto in 1930. A piece of Spaceship One, the first private spacecraft to reach space. A stamp from 1991 that reads, "Pluto not yet explored," which the Postal Service issued before anyone knew if we would ever go, and a CD with 434,000 names of people who wanted to be part of the journey. Those names are now past Pluto, past Arakoth, heading into the interstellar dark at 31,000 miles per hour. That disk will outlast the spacecraft. It will outlast the engineers. It will still be traveling when the sun has become a red giant and the Earth is no longer a place where biology can survive. The most permanent message our civilization sent to the edge of the solar system runs on less power than a single household light bulb. The most complete portrait we have of a complex living world at the outer edge is stored in a machine that will go permanently silent within the next decade. Not because it stopped working, because there was no longer enough power. Not because we lacked the technology, because we chose not to return. The signal is still coming. The data is still arriving, packet by packet, across the 5 billion mile gap. The question is whether anyone is paying attention. If this story mattered to you, subscribe to the channel and hit the notification bell, because we cover the missions that change how we see our place in the universe, and we do not look away. Leave a comment below telling me what surprised you most. And share this video with someone who needs to understand that the edge of the solar system is not dead. It is waiting. And right now, we are letting the only phone line go quiet.